This is Chapter 4, Unit 1. We're going to talk about variability. Variability refers to how far apart or even how close together scores are from each other. So here's an example. This is an example of the time that rats took to solve a maze. So they did a bunch of different trials. So the first trial, they recorded the times of how long it took them, and the average was 12 minutes. And finally, when they did the 10th trial, the time to solve them was much less, with a mean or an average of only 2 minutes. Okay, and 6 rats took place in this trial. So trial 1, let's look at the range of scores. The lowest one is 5, the biggest one is 19. So, and remember when we're talking about time, it's a continuous variable. So when you find the range for continuous variables, you have to do the biggest score minus the smallest score plus 1, or you can do the upper real limit of the biggest one, which would be 19.5, minus the lower real limit of the smallest one, which would be 4.5, and you'd get the same answer. Variability is very high in trial 1, covering a range of 15 different points. Scores are up to 5 points away from that mean. Once you found the mean of 12, you can have scores that went all the way down to 5, all the way up to 15. They can be like, 5 points away. That's pretty variable. Let's look at trial 10. The scores range from 1 to 4. The scores only cover a range of 4 points. And again, the shortcut is just the biggest minus the smallest plus 1. So you get 4 points. Variability here is very low. The scores are only 1 or 2 points away from the mean. All right, let's look at more about variability. So variability, in essence, provides a quantitative measure of the differences between scores in a distribution, and it describes the degree to which the scores are very spread out or they're very clustered close together. And you can see variability a little bit easier when looking at a graph. So let's look at the graph here. Let's look at heights of adults, and these are males, and let's look at weights of adult males. Well, look at the first graph of the heights. This tells you that most men are between 58 and 82 inches. They are very, very close together, very low variability. You can see how the graph looks. However, when you look at weights, notice the graph goes from 110 pounds all the way up to 230 pounds. The graph is much more stretched out. That's called high variability. There's a lot of variability in how much males weigh, right? It would be typical for someone to weigh 120 and another male to weigh 230. It's just very variable because the weights are so different from each other. Okay, let's look at the purposes of variability. The first purpose is just to describe the distribution of scores. You usually describe it in terms of a distance. Extreme scores are usually rare. Okay, the second purpose of variability is that it can measure how well one score or a group of scores represents the entire distribution. So for example, if I had a classroom and they scored, say, an 87 average on the final exam, and I taught that same class 3 other times, and the class averages for the other classes are only like 75, well, does that one class with an 87 really represent the entire population of all my classes? I'm not sure, but that's what variability can help tell us, okay? When using a sample to represent a population, the variability provides how much error to expect between the sample data and the population mean, okay? So for example, if I chose that sample that had an 87, well, that's really not representative of my whole population of all my classes added together, which say had an average of, say, 82. So that's called error. We'll talk more about that in a little bit. So definitions of range, we talked about it. You can have the largest minus the smallest when you have discrete data. In this class, most of the time, we're going to have continuous data, so we would use largest minus the smallest plus 1. The range is highly influenced by outliers. Okay, it's not a really good definition for variability because it can't really reveal the typical distances between scores. Okay, So say everybody made between like say 50 was the lowest score and 100 was the highest score on a test, well, you'd say the range is about 50 points. However, what if everybody really made between a 50 and 60 and maybe one person cheated and they made 100? Can you see how the range wouldn't really reflect that really good, because most people made between a 50 and a 60 and only one person made 100. But you don't know that if someone just tells you the range is 50 points. All right, so let's talk about the interquartile range. It's a much better estimate of variability. It's the range of scores that make up the middle 50% of the distribution. So basically, we don't care about the lowest 25% of scores and we don't care about the highest 25% of scores. We only care about the middle 50%. Okay? So basically, you can think of the interquartile range as like a dollar bill, and you want to find the percentile rank at the 25th percentile rank. That means how many people had scores greater than the 25th percentile rank. That's Q1. Q2 is the 50th percentile. People had scores at 50% or lower. Q3 is the 75th percentile, so people had scores the 75th percentile or less. And Q4 would just be everybody's scores, 100%. So for the interquartile range, we only care about Q1 and Q3. And remember, keep in your mind, quartiles are determined using upper real limits. So the interquartile range is very useful because the lowest 25% and the highest 25% are excluded. So that means there won't be any outliers to influence the interquartile range. This is typically used in conjunction with the median. And you'll notice in a minute that the calculation is very, very similar to the median. It can also be used when your data set has undetermined values or open-ended distributions. It's very useful for the ordinal scale of measure, just like the median. So let's look at an example. So consider these scores from a continuous variable. So step one is you always put the numbers in order. Okay, and if you want to, you can make a graph of them so you can see what they look like on a histogram. It might be easier for you to think about this. Step two is find n. Well, if I count how many scores there are here, there are 20 scores. And remember in the median we divided it into two parts? Well, this is a quartile, so we're just dividing it into 4 parts. The calculation is exactly the same, so n divided by 4 gives us 5 points. So there are going to be 5 scores in each quartile. So you're going to list your scores, count over 5 of them, and put a slash mark. Going to count over 5 more and put a slash, count over 5 more and put a slash, and then that's the end. Okay? So you're going to notice you're going to have to find quartile Q1 and Q3. Well, the first slash mark is at Q1, and notice there's a 10 and 11 on either side of the slash. So we're going to do the same thing we did with the median and find the average. Add them up, divide by 2. The average of 10 and 11 is 10.5. We're going to do the same thing for Q3, which is the last slash mark. Well, there's a 13 on the left side and a 14 on the right side, so you just add them up and divide by 2. 13 plus 14 divided by 2 is 13.5. The final step in finding the interquartile range is you just subtract. Q3 minus Q1, you get 3 points. So the interquartile range here for this problem is 3 points. Okay, let's do a learning check. Pause the video and see if you can do the problem. Okay, for this problem, what's a consequence of increasing variability? Okay, so if you increase variability, the distance from one score to another tends to increase. Remember, think of the graph, how it gets more spread out. And a single score provides a less accurate representation of the entire distribution. Okay, so it would be B. Learning check problem 2. What is the range for the following set of scores? Pause the video, see if you can figure it out. Okay, well, if we assume discrete data, then we just say 15 minus 5 and we get 10 points. If we assume continuous data, we say 15 minus 5 plus 1, which is 11 points. So I would accept either answer in this case. Learning check problem 3. Again, pause the video. Okay, which of the following will increase the range? Well, first off, let's figure out what the range is. The range We'll just assume that we have discrete data since we're not told. We'll say 15 minus 3 is 12 points. So the range of the original distribution is 12 points. Well, if we add 4 points to the score x equals 3, well, now we have scores of 7, 10, and 15, and the range is 8 points. What happens if we add 4 points to the score of 7? Well, here's the new scores, and the new range is 12 points, same as the original. All right, part C, add 4 points to the score x equals 10. Well, here's our new scores. 10 is changed to 14, and the new range is 12 points, same as the original. Finally, add 4 points to the highest score of 15, and so it ends up being 3, 7, 10, and 19 for the scores, and the range here is 19 minus 3, which is 16 points. So basically, if you want to increase the range, you have to either increase the highest score or decrease the lowest score to make the range bigger. So the answer here is D. The range is now 16 points. All right, learning check problem 4. See if you can find the interquartile range. Pause the video while you do this. Step 1, put the scores in order. Step 2, find n. How many are there? Well, there's 20. Step 3, divide it into 4 quartiles. So 20 divided by 4, that means there's 5 scores in each quartile. So put a slash after every fifth number. Find Q1 and Q3. So Q1 is where the first slash is, and so you average 2 and 3 together and you get 2.5. Q3 is where the last slash is. So you average 4 and 5 and you get 4.5. All right, step 6, find the interquartile range. You just say Q3 minus Q1 and you get 2 points for this problem.